Cool. So yeah, I'm very excited to be here today, and I'm going to talk about kind of a research project a coworker and I have been working on for a few years now, and has to do with basically us trying to figure out if mobile devices all around the world are being targeted for traffic interception or man-in-the-middle attacks, and if that's the case, why and where, and trying to figure out what's going on again in the world. And to do that, we've had access to a set of 10 million reports about SSL incidents around the world. And I'll explain what this is, but this is basically where all the data we have is coming from, just as a quick intro. We have obviously a lot more data coming from the US, and I'll explain. But basically, we've analyzed man-in-the-middle attempts all around the world to try to figure out what happened. Was it your employer, or was it something else? Again, looking at 10 million reports, so 10 million attempts. So first of all, I'm gonna talk about how we were able to get access to all these reports, that data set. And then I'll talk about the data set at very high levels. So something like where's the data coming from, which countries, what does it look like at a high level, and also how we analyzed that data. And then, of course, I'll talk about the result of that analysis, which is really trying to answer the question, who, what, where is mobile traffic getting intercepted, and why? And then, of course, a quick conclusion. But first of all, so you saw that map with all these dots, and you might be wondering where did they get access to 10 million reports about man-in-the-middle attacks. So it all started a few years ago when we released an open source library called TrustKit. And actually, some of you in the room have worked on it. And what it does is it makes it easy for developers to make their apps network connections more secure using two mechanisms that I'll explain in a minute, SSL reporting and SSL pinning. And so I'll quickly explain what TrustKit does, just so then you can understand where all the data that I'm going to be presenting is coming from. So the first thing the library does, so it's an iOS and Android library, is SSL pinning. I'm not going to spend too much time on this, but the idea of SSL pinning is when your app is connecting to its server using TLS or HTTPS, it's going to check the server certificate, make sure the certificate is trusted, make sure it was issued for that host name that you're trying to connect to. So that's the default OS validation. SSL pinning is when you want to add an extra step to that validation at the very end. And that extra step, it's basically hard coding the key that you know is going to be used on your server. So if you look at that certificate chain for dataserver.com, if an app is trying to connect to that server, first it's going to do all the default validation. And if you do pinning, you're also going to be requiring the certificate chain to contain the key that you know is used for dataserver.com, or some intermediate certificate in this case. And so you get that extra step to validate, and the real implementation is to hash the public key data. You get a hash like that, and that's an SSL pin. So in your app, or when you're using TrustKit, you have that extra validation, which is, okay, the certificate is trusted, it's all good, but now does the chain contain that one key that we know is being used on production? Because if it doesn't, then that chain might look like it's valid, but it's not the one that's on our server, so what is it? And that's SSL pinning in a very quick intro. The other thing that it does, and this relates to our research, is what we call SSL reporting, which is if something goes wrong with the TLS connection, the certificate is wrong in one way or another. It might be wrong because the default OS validation failed, so the certificate is expired, or the name doesn't match. The CA, it goes all the way up to isn't trusted. That's when the default validation fails, and then when pinning validation fails, which is all of this was fine, but once you get to that extra step, pinning validation failed. And so SSL reporting is the idea that you want to send a report letting you know about this, that this just happened for one user using their phone somewhere in the world. That's what we've implemented in TrustKit, and so it looks like this. There's some data about the app, so we know which app it is, but mainly the host name the app tried to connect to, and then the certificate chain that the app received when it was connecting to that server, which clearly is probably not the right certificate chain. It's probably not the one that's on your server. It's something somewhere in the middle that's trying to mess with your connection. And we'll go into the details of that. But that's basically a report you can get again when something goes wrong with TLS. And so the idea with that is that you get a report so you can see what's going on across all of your user base. You know how many users are getting their traffic intercepted and why. So we think it's pretty valuable. And so when you enable that in Trustkit, you have the option to send the reports to our server, which is hosted by the Ethereum for free. And if you enable that as a developer, you get access to a dashboard that shows you some details. But the whole idea of SSL reporting is that you're able to tell when something's happening and how many of your users are getting problems with their TLS connections, and even spikes. And I'll give an example later. Spikes of report meaning something's happening somewhere in the world. So I'll do a quick demo just so it makes more sense. It's a recorded demo, and so on the left you have a real iPhone, and that iPhone has been configured. Oh, sorry, is this here? Okay. So on the left you have a real iPhone, and on the right, so that iPhone has been configured to have all of its traffic go through a proxy, which in this case is Burp, which some of you probably have used before. Yeah, so that's a real iPhone, it's not the simulator. And then I'm gonna build an app and run it on this phone. And what the app does, all it does really is it's just connecting to a domain, to datathron.com, using the normal APIs. But that app has Trustkit configured. So I'm building it, launching it. The app doesn't do anything, but you can see in the logs some errors. It's probably hard to see, but I'll read. Pin validation failed for datathron.com. So Trustkit is complaining because pin validation failed. And then it says report was sent to something. So that's basically everything I just described. And you're going to see in Burp the report that was trying to get out to our server that has all the data I just described, including the certificate chain that caused the problem. And in this case, the certificate chain that caused the problem is the certificate chain that caused the problem, sorry, is the one that's used by Burp to try to intercept the connection. So this is basically the Burp certificate chain. So the app was unable to connect because Burp is sitting in the middle and the app can connect. And this is our internal dashboard. And so once the report has been sent, we receive it, and then we see all the data in that report. So when it was sent, the domain it was trying to connect to, and then the certificate chain that caused the problem. And in this case, it's port trigger CA, which is the certificate chain that's used by the Burp proxy. And then we do some analysis, which I'll explain later, where we say, okay, this is clearly a testing tool, and this is the Burp proxy, basically. So that just kind of summarizes everything I just talked about. And now back to the research. So the data set, as I said, we've received 10 million of these reports, and so they come from all the apps that are using Trustkit and that have enabled that feature where they send the reports to us. So we've received reports from about 2,000 different apps, mainly from iOS, not because iOS is getting more targeted or anything like that. It's because we have a lot more apps on iOS that are using the library. On Android, we released the library a lot later, so we have less apps that are using it. And there's like maybe 2 tvOS apps or something that are using it. So 2,000 different apps, all kinds of apps, banking, shopping, news. And if you look at per countries, again, this doesn't mean that the US is less secure or there are more attacks. It's just how much data we're getting from each country. And so mainly the apps that we are seeing and their user base are mainly in the US, which is why we're seeing more data coming from the US. But one thing that's cool is we've received at least one report from every single country in the world. But most of the data comes from the US. We have a few big apps in Taiwan, so we're also getting, that's why Taiwan is third. But yeah, so just a high level overview of the data set. And then other interesting things, we've seen more than 3 million unique certificate chains. So again, that certificate chain that caused the problem, that wasn't the real one probably. And also among all these reports, 22% of these reports in the certificate chain that was bad did not match the server host name. So it wasn't actually an attempt at decrypting the traffic or intercepting traffic. It was just either a misconfiguration or some kind of captive portal, and I'll talk about that in a minute. But that's what we call non-man-in-the-middle incidents. So that was 22% of the reports. So that's basically the data at a very high level. And so the way we analyzed each report, we use different things, but honestly, it usually all comes down to the certificate chain. And so we look at the certificate chain and all the fields, like the issuer, the subject, and try to figure out, okay, what is this? Is this burp? Is this some network device? Is it someone's employer? And we have basically a huge rule set trying to figure out what this certificate is based on, again, field, or you can add a rule for a specific certificate, like a known bad CA, like the one that was used for the Pegasus attack. We have a rule for that. We haven't detected it, but we have a rule for it. So anyway, you can do all sorts of rules, but to give an example, that's the rules, some of the rules we have to detect tools, like pen testing tools and developer tools. So it's just a YAML file. It's pretty simple. The first one is the one you saw live, port trigger. So it's the one that detects the burp proxy. And so it just tries to look for port trigger CA as the subject of the root certificate. Fiddler is the same. Fiddler is another tool you can use to proxy apps. Except the subject is always called do not trust Fiddler root, which makes sense because you shouldn't trust it. Then Charles proxy is slightly more complex. You have to use a regular expression because the content of the subject changes. One thing you have to be careful with Charles proxy if you're using it is that it sometimes puts here your name, and then it's kind of obvious who it is. Because I think it uses the computer's host name, and on Mac OS, the computer's host name can be your first name and last name. But overall, the rule is pretty simple, and then other tools. So that's kind of how it works, looking at the certificates in the chain that was received, and trying to classify them. I'll give another quick example. So this is a report we've received on our server. All the data I just talked about, the app name, the app package name, the host name. But again, the main thing is the certificate chain. And if you parse the certificate chain, you get the certificates. And in this one, the common name, the issuer is FortiGate CA. So it goes through our set of rules. And in this case, let's say that's all the rules. There isn't one for FortiGate CA. There's one for Cisco Umbrella, which is another type of appliance. But there isn't one for FortiGate CA. So then it just, the server flags the report for manual review. So someone has to look at it and try to figure out what this is. And then someone looks at it, see that it says FortiGate CA, it's probably going to be Googling FortiGate. And then we know it's actually a brand of appliance from Fortinet, which is pretty easy to figure out. And then we just add a rule, and then all the next reports that come in with this get automatically flagged as a corporate appliance, and the brand is Fortinet. So that's how the analysis work, at a very high level. And we have, I don't know how many rules like that we have, but probably hundreds that we've built over time as we kept getting more and more reports from new devices or new things. So that's how we analyze the data. Now, of course, what did we find? That's probably why everyone is here. So as I said, we've analyzed about 9 million reports, and we've grouped them into different categories. And these are all the categories, and I'll talk about each one of them in details. And I'll talk about this one last. It's probably the most interesting one, but and among all these categories, we've split them into two groups. Something I mentioned earlier, what I call the non-man-in-the-middle categories, which are for SSL incidents when the host name didn't match the server the app was trying to connect to. In this case, whatever happened, it wasn't trying to decrypt the connection or spoof the server or do anything. It's just the certificate was just completely wrong for that server. And that happens, there are various reasons why this happened. The number one reason is captive portals, which I'm sure you know about. So it's when you're, so 11% here, it's when you're at the hotel or at the airport and you haven't logged into the portals page to get connectivity. So you're on the Wi-Fi, but you haven't done the login flow. So you have like some connection, but you don't really have the internet. And some of these portals, they do everything they can to redirect you to the login page. But if you're using TLS, they just push their certificate. That's just wrong. And then it's just causing failures. That's the number one category, but nothing too surprising. We have some reports we haven't had time to look at yet, but so we'll get to that. But again, it's non-man in the middle, so the hostname didn't match, so it's not going to be a huge deal. It's not going to be something that was trying to spoof the server. The next one, which is interesting, server misconfiguration. So in our case, it's mainly one thing. It's when the server certificate expired. And that's 4% of the reports. And we saw that happening live actually for one app where everything was fine, and then the certificate expired, and then we started getting tons of reports because the certificate was wrong, and the app basically couldn't connect anymore and stopped working. So it's a pretty big number actually of servers that are misconfigured. Unknown, that one is interesting. Unknown is for, so as I was explaining, most of the analysis we do is on the certificate chain, but sometimes we get a certificate chain that doesn't really have anything we can use to figure out what it is. Sometimes it's a certificate issued for our local host and it's self-signed and there's nothing, no company name, nothing. So then we have no idea what it is. And this is that category right there. So it's when we don't have enough data, enough information to make any conclusion, which is sad, but there's not much we can do about that. And the last one, client clock misconfiguration. It's when your phone doesn't have the right time. When the time is wrong, then you're gonna have TLS failures because maybe on your phone it looks like the certificate is expired, but it's not expired, it's just your phone's time is wrong. It's a very small number, as you can see, which is interesting because a few years ago, Google released some similar stats for Chrome desktop and Google.com. And the client clock misconfiguration was the number one reason why Chrome wasn't able to connect to Google.com. Not too surprising, of course. I think phones are much better at figuring out what time it is than desktops, but still an interesting difference. And that's all for the non-manual categories. So again, these things were when the certificate was wrong. So whatever device or captive portal was there wasn't trying to spoof the server. It was just a failure. And the next group is what we call man-in-the-middle categories, which in this case, the certificate chain had the right host name. So it was definitely trying to pretend it was the server, the real server. And I'll start from the bottom. The first one, dev, what we call dev artifacts. It's the one you just saw in the demo. It's developer or pen testing tools. The most popular one is Charles Proxy. It's the one that most mobile app developers use, but OWASP Zap is here. Fiddler, Porttrigger. If you've done any kind of web pen testing, you know about all these tools. And obviously we see them in the reports when they're used to try to manipulate an app. But it's more like developer tools. And again, nothing too surprising here. And then the next category, corporate networks, nothing too surprising either. It's basically your employer who has set up traffic interception to try to manage all the data coming in and out. And so we can see all the, the brands, all the different appliances that are used. And that's 2% of all the reports we've had. And so for this, in this case, basically what happens is maybe, at work you are given some kind of phone that's on the corporate network, and that phone has the IT team's private CA pre-installed, and it's probably also using a VPN. So the phone has a custom CA, which is probably the CA used by the device that's being used to intercept the traffic. And then your device traffic is getting intercepted. But again, that's, your employer would have notified you and you would know about it. So nothing too surprising here again. So that's for corporate networks. One thing that's interesting about this category, so it's sometimes called lawful interception. So one thing we looked at was, okay, so we have these devices that are intercepting the traffic, and they're probably your employer and you know about it, and so it's, again, lawful interception. But one thing we've seen, and there has been previous research about that from Facebook and Cloudflare, I think, and Mozilla, is that these devices that are put in the middle, they actually tend to downgrade the security of the connection. And so for 30% of the reports, when the real server's key was 2048 bits, the key that was used by the intercepting device was only 1024 or less. So that device sitting in the middle where your phone is here was downgrading the security of the connection. So that's not great. And there's I won't go into that, but there's a big debate about that around TLS 1.3. But I think TLS 1.3 is about to be released, I think so. But anyway, it's a big thing with lawful interception. And then the next one, pin misconfiguration, 34%. That one was kind of scary. So pin misconfiguration means that you misconfigured TrustKit in your app. And so you set up pinning, but the pin, that hash I showed at the beginning that you used, is not the one that's on the server. So the app tries to connect. The app is wrong about the server's key, so it thinks everything is failing. And when you use TrustKit, you can decide if you want a pinning failure to be a hard failure, where the connection just gets canceled, or if you still let the connection go through. And so if you haven't enabled enforcement for pinning, your app still works, but it's sending tons of reports, because every time it's connecting, the pin it's expecting isn't there, and it thinks the server is wrong or something. So we get lots of reports. And if you are enforcing pinning in your app, then your app just stops working because it cannot connect anymore. So 34%, that number is kind of inflated because, again, as soon as the app is misconfigured, we get lots of reports for every single connection. However, we looked at a different number, which is among all the apps that we can see, how many did have at some point a pinning misconfiguration, and that's 22%, which is huge. Again, if you have misconfigured your pins, your app will probably stop working. So the reason for that, there's a lot of pressure on mobile developers to do this thing called pinning and be secure and everything, from all sorts of reasons, the security team, bug bounties. But the truth is, most apps don't really need pinning being enforced. And there's a huge, if you decide to do it, there's a huge overhead, and you have to be ready for it because, again, as if the key on the server changes or is not the one you think it is, your app just stops working. And it's not just an abstract idea, it actually happened, and it was pretty bad. It happened to a mobile app from Barclays, the bank. The mobile app was their version of Square Register, so it was an app for stores to take credit card payments. So you'd have a phone and you would pay with your credit card, and they would use this app to process your payment. So if you read the title, so it was end of 2016. Users have been left without the possibility to pay for purchases due to legacy intermediate SSL certificate, which sounds kind of odd, but let me explain. So the Barclay app was configured to do pinning on this one. So that's the certificate chain for the API. And the Barclay app was configured to do pinning on the intermediate certificate, which is this one. So it had everything set up correctly, everything was working fine. The app connects to the server, gets the certificate chain, sees that this is the right key, and everything works fine. However, the server team renewed the certificate for this one because it was going to expire. And when they renewed it, the CA gave them a new certificate, but also with a new chain. So this one changed with the new certificate chain. And as soon as they deployed it, then the app would connect, and this would be wrong according to the app, so the app wouldn't work anymore. So the result was going to be several thousands of customers of small and medium-sized businesses will not be able to perform any transaction during Black Friday and during the holiday shopping period. This will affect hundreds of thousands of customer transactions until the application is updated and then released again. So yeah, that was pretty bad. And it got even worse because Barclay didn't want to go through that, obviously. So they asked their CA to do a special, to issue a special certificate that was still using the old intermediate. But to do that, the CA, I'm not going to go into details, but to do that, the CA had to break a bunch of rules. So then the CA was in trouble. And now I don't think they exist anymore, but I'm not gonna, you can figure out who it is. Yeah, so anyway, all starting from this idea of we must do pinning and now this, so you really have to be careful. And again, we've seen 20% of the apps we can see getting it wrong at some point. So I feel like this is not something that's well known, like the huge, I mean, it's better now, but it's a huge overhead and risk when you want to do pinning. And then finally, the last category, which is probably the most surprising one, at least it was to me, spyware, 39%. And we've split that into 3 subcategories. And I mainly talk about this one, market intelligence, which is where most of the reports are, more than 3 million. And then parental control and ad blocker, you can probably guess what this is. But first, market intelligence. So it all started when we were getting reports, as always, and these are the names in the CA, mobile expression, digital reflection, and all these ones. But it's mainly one company called Mobile Expression, which I'll talk about, and then the next one, digital reflection, it's actually the same company. So that's mainly who we looked at and who investigated. So again, mobile expression is the name in the CA. When we get the report, we see mobile expression. And we get lots of reports across, about 20,000 devices, and it's only on iOS. We haven't seen it on Android. Again, we have a lot less data on Android. So as I said before, when we get a report about something we don't know about, we just Google it. And so if you Google for mobile expression, you find that it's an elite market research community dedicated to improving the mobile internet. And mobile users are invited to join our panel and help shape the future of internet simply by sharing your mobile surfing activity with us. So it's like pretty clear actually that there's something going on here. It was still surprising to me because I wasn't sure how that technique that would work. Like, how would you share your surfing activity with them or anybody? And so I'm going to do another quick demo to show you guys how it kind of works. I don't know which screen. Okay. Yeah. So don't look at what's behind. That's the old demo. I'll put it in the middle. So that's an iPhone again. And so if you go on the App Store and you search for mobile expression, you find them. There's an app, and it's by this company called Voice5. And they actually have 3 different apps. TV check-in, DR is actually digital reflections, mobile expression, and My Mobile Secure, which is like a VPN, ad-free proxy VPN client. One thing that's interesting is that users become members of the mobile expression research community. And that's something you're going to see in every other app, but pretty good reviews actually. DR, so it's digital reflection, members to easily participate in our community, and other things. And then the main one, mobile expression, same thing. You can help improve the mobile internet and earn rewards, earn prizes, including cash, gift cards, and other things. So if you install the app, and then you open it, so you have to activate it. And when you do that, you get kind of they tell you what you're supposed to do, and then you might be able to win a prize in only 1 week. Amazon gift cards, speakers, HGTVs. And so if you click on Start Now, one thing you didn't see is it does show a privacy policy. It's just I had already accepted it before doing the demo, so there's a privacy policy. But if you click on Start Now, it goes into that screen that says Install Profile. And it says the profile prepares your device for participation in the mobile expression community. And it says contains email account, VPN settings, and 2 certificates. If you look at that, yeah, so there's a VPN, the mobile expression CA, which is the thing we were looking for in the first place, and then even an email account. It adds an email account to your device with a username and the password and everything. And they actually use that to send you notifications. So if you click on install, then it does give you a warning. So it will add the certificate to the list of trusted certificates on your iPhone. And with the VPN, the network traffic of your iPhone may be secured, filtered, or monitored. And then once you install that, you have to pay attention to the top of the screen because something's going to happen. Okay, profile installed, and then you can see the VPN icon showing up. And now I'm activated. And so now it seems like I'm on a VPN, right? And so then going back to the app I showed in the first demo, which just connects to datathrone.com. If I run it again, this time you're not going to see anything, but I'll show you in the next slide. So I just launched it, and then it wasn't able to connect. And going back to the slides, on our server that's receiving the reports, we could see one report for datathrone.com and the mobile expression CA, which is the thing we've been looking for this whole time. And obviously I classify it as spyware. So basically that app tried to connect to datathrone.com and then ran into an unexpected certificate chain, which is the mobile expression CA certificate chain. Yeah, this. So what happened there? So depending on how familiar you are with iOS, so a configuration profile was installed on the device. A configuration profile is a very powerful tool that lets you configure an iPhone, basically, an iOS device. And it's mainly used by IT departments to enroll your device, your phone into the corporate environment and the VPN and email. So it has access to a lot of different things. And in this case, the profile installed an always-on VPN so that all your phone's traffic goes through their servers. And then it also installed a custom root CA. And if you have these 2 things, you have everything you need to decrypt all of the phone's network connections. Because all the traffic goes through their servers, and then here they have the key for their CA so they can decrypt all the connections. Yeah, so was kind of surprising to me. And then, so you might be wondering, who's mobile expression and why are they doing this? So it's actually pretty easy to find. They're not hiding anything. So they say it's a service of Comscore, a global leader in measuring the digital world, providing insights into customer behavior and attitudes. So they're owned by Comscore, and Comscore owns a bunch of apps, including mobile expression and digital reflection. And what we saw there was they promised some kind of reward, like a gift card or an HDTV or something, if you install the app and the configuration profile. And so some users, they have, I don't know how many users they have, but they definitely got people to install it. But then they don't get very good reviews. So there's this review, which is pretty telling. They spent 4 weeks collecting data from my phone. First week I won an Amazon gift card, which I never received. Then they never gave any more rewards when they say you get something each week. Contacted customer support and they never replied. I gave them a week and still nothing. But the final, I like the final sentence, which is pretty, they got my data for free, don't be like me. So yeah, pretty sad ending. So, but that's basically how kind of the model of these apps. And it's not just Comscore, but I think they're the biggest one. And so if you look at Comscore's website, so yeah, they say like this capability is based on a massive global cross-section of 2 million consumers who have allowed Comscore to collect their online browsing, hardware and application usage, and purchasing behavior. So basically, their business model is they sell to other companies information about app usage. So if you are a company who's building some app, maybe you want to know more information about your competitors, how well they are doing, are people using them, or which apps is currently like exploding right now and is getting tons of traction. And they also, sell things like measuring how well your ads are performing. So all sorts of things, but to do all that, you basically need to decrypt and insert all the application's traffic. Yeah, so we uniquely combine massive scale with smart method to turn data into value. So yeah, they're a measurement company. So that's, I mean, yeah, there's nothing illegal or I guess I would say it's still kind of shady, at least a gray area. You might be wondering, okay, how can we do anything about it? And it's kind of tricky actually because so one thing you could say is, okay, let's get rid of configuration profiles because they're so powerful and you're just one click away from installing something crazy, right? But it's difficult because they're used again by IT departments to set up devices, so you can't just get rid of them because there's a real use case for them. It's just that they're getting abused in this case. But it is pretty bad because if you're a normal user, if you're not technical, I don't think you can really understand the warnings and what it means and what you're really installing. And there are other things that are kind of confusing. For example, the profile, it doesn't get uninstalled if you uninstall the app. The profile has actually nothing to do with the app. When you're in the app and you install the profile, it actually opens Safari to install the profile. So the app is completely disconnected from the profile. And all these things kind of make sense if you understand how it kind of works, but for a normal user, it makes no sense. Like if you uninstall the app, the profile shouldn't be there. But yeah, so getting rid of profiles is not an easy thing to do. And you could also ban the application from the store, but again, all you need to install the profile is Safari. So if you just open one in Safari, you can install it. I still think it would be better to ban it so people can't find it, but it doesn't prevent this whole scenario. Yeah, so I'll talk about it again at the very end, but that was market intelligence. So pretty interesting. And then the two last subcategories, ad blockers. So I'll briefly talk about those. It's very small numbers compared to that, as you can see. The one we've seen, so technically it's the same implementation. It puts you on a VPN with a custom CA. We've seen one on Android called Defend My Wi-Fi. Automatically turns public Wi-Fi into safe and secure private Wi-Fi. I don't know if I would agree. And the company doesn't exist anymore. So the app, I think the app is still on the store. Or I don't know if the app is on the store, but we're still seeing reports of people who still have that installed. But I don't think the company exists anymore. So that's one thing. It's once you've installed that, unless you know where to go and like it's in the settings pretty hidden, it may not be obvious how to get rid of that if you're not technical. And another one we've seen on iOS is AdBlock Mobile. But what's interesting is initially around iOS 8, again, you would install it, same thing, put you on a VPN, install the CA, and then it would man in the middle all the ad domains. So not all domains, but just the advertising domains. But then they got removed from the store. I don't know why. I don't know if it was Apple or them. And then they got back on the store, but this time they don't install a custom CA anymore. Which makes sense because to block ads, you don't really need to man in the middle of the connections. You can just block the connection if you know it's an ad domain. So yeah, I don't know if Apple was involved, but it's pretty interesting. And then the last one, parental control. Yeah, it's mainly one called QStudio. It's just tools you install on a phone if you want to kind of spy on them or just monitor what they're doing on the phone. So yeah, parental control. One of these tools, I don't remember which one. I like it because they call the person spying on you is called an accountability partner, which I think is pretty funny. But basically, it's just tools to monitor a device. And that was all the analysis and the categories we've found so far. So to conclude, so something we knew already before looking to that is, of course, traffic interception does happen, at scale anywhere in the world. At least we knew about the employer use case, right? And so usually it's not malicious. Again, if it's your employer, it's not really malicious. We've seen a lot of reports where users are willingly sharing their data for a reward, and the reward might be, again, a gift card or something, or maybe the promise of security or blocking ads or stuff like that. For me, this area is, again, kind of a gray area. I don't like it a lot, but there's nothing, we haven't seen a lot of anything from Apple or Google on this, and mobile expression is still on the store right now. You can download it if you want. So I really think it's a gray area, and even there's a privacy policy. Everything is there, but I'm not sure it makes sense, and I don't think users have a chance of really understanding what they get into, and that App Store review I showed you kind of proves that. Yeah, and then another thing I talked about, which was this pinning misconfiguration, which was the second biggest category. And so it goes back to all these examples of traffic interception. And I think as an app developer, you have to ask yourself the question, is the data within my app, is it so sensitive that legal or lawful interception is okay and it is fine if the user's employer can see it? And if that's okay, I mean, if it's a game or, again, an app that actually needs to be used on the corporate network, then you're probably fine. You don't really need to do anything. But if you feel like the data is so private that even the employer shouldn't be able to see that, and a good example is mobile banking, then that puts you up in a different category. And if this is the case, one way to technically enforce that is SSL pinning. But if you're fine with lawful interception, you don't need to worry about this, I think. But if you're there and so you want to do SSL pinning, the good news is you have more options on mobile compared to the web. So on the web, there was a spec to do pinning, which I think is pretty much dead now because it was very tricky and very easy to make a big mistake. But what we've seen that works well is using this thing we call SSL reporting, probably has other names, where you can see how many of the users are getting are seeing man-in-the-middle attacks or getting their traffic intercepted and see how big of a problem it is and who's doing it. And based on that data, you can make an informed decision on whether you actually want to go ahead and do pinning or you think it's probably okay. Again, you should only do pinning if you really feel like your app needs it. It's a huge overhead and there's a huge risk of catastrophic failure, like what happened to Barclay. So you really should think twice before doing it. And if you want to do it, it needs to be planned carefully. The server, it's fine. It was for the end. The server team needs to be involved because they're going to be rotating the keys and the certificates. So there needs to be a lot of communication happening for this to succeed. And one thing I've seen a few times is where the main reason for doing pinning is to prevent reverse engineering of your app. If that's the main reason, you're going to run into so many problems, and it's not very efficient at preventing reverse engineering anyway. So this as the only reason is not a very good reason, I think. So something to think about. That's all. Thanks, everyone. Any questions? Yes. You have to wait for the microphone.
Do any of the mobile app security checks, like, you know, mobile safe or anything like that, pick up the insertion of CAs to detect this? Because any application could install a CA.
So I don't, on Android, I would think yes. I'm more familiar with iOS. On iOS, I don't think an app can detect that. If you're set up as an MDM, so you have like special admin privilege on the phone, so it's like, again, your IT department, they probably can detect that. But an app by itself, trying to see the list of CA that's installed, that you can't do that on iOS. Yeah. Oh, okay.
So in your research, were you able to find out who exactly was purchasing that information from Mobile Force and whatnot? Because it's really shady how they go about it. And, you know, as a business, let's say if you're a business owner, would you be like, well, do I really want, they took it from very unethical means. Do I really want to purchase data for that? Is it even viable at that point?
So I think the buyer of the data is only maybe half aware of where it's coming from. They kind of know, but not really. But if you think about the top 10 tech companies, they're probably buying this. So, yeah.
Do you see any apps using like the public key pinning to like do different things once they see like an interception, like maybe like a big warning bar across the top, or like maybe not letting you change data?
Yeah, so I've seen the different ways to handle that. Honestly, if it's happening in the app, again, the best thing you can do is send a report so you're aware of it. Showing something to the user can't do anything about it. So the best thing you can do, I think, is say, oh, the app is unable to connect. Try again later or something. Because they're not going to be able to do anything.
Do you take a view on using certificate transparency instead of pinning as a way of trader tracing and finding out when someone's man in the middling your app?
Yeah, I mean, I think certificate transparency is great. It has proven already multiple times that it's super useful. I think you can use both because certificate transparency, well, right now at least it's too early to use it so that it would block the connection if something is bad with the certificate chain. To do that, to block the connection, you need, right now at least you need pinning. I think there are mechanisms eventually that you'll be able to use where if the certificate is not in the transparency logs, then it doesn't connect. But I don't know how, like, I don't know if this is already available, and yeah. Oh yeah, it's amazing. Yeah, for sure.
So 2 questions. One, do you know of any tooling to help track changes to the certificates to help you update your pinning? And second, do the libraries for doing the pinning validation support checking against multiple public keys so that you can transition from one cert to another?
Yeah, so I'll start with the last question first. Yeah, so all the pinning library, all good pinning libraries should let you pin multiple keys. Yeah, that's something you really need. So, and it's part of the strategy you should follow if you're doing this, because you need to pin one key that's the one that's being used right now, And you need to also pin another key, which is a backup certificate. If something goes wrong with the one you're using, you can quickly swap, and the app already knows about it. So by design, your pinning library must be able to do that. If it only supports one key, then that library is not you should not use that. Your first question, monitoring when the certificate changes. I don't know. There has to be some service that does that, but I don't. Well, yeah. If you want to do it yourself, you can. Like always.
I'm not sure, but does HSTS help prevent this, assuming that they've connected to you once successfully the first time, so that that connection is cached? I'm not sure if more than don't use port 80 is cached than beyond that, such that it might have the key or the hash rather.
Yeah. So HSTS is more. It does something similar, but it's more in the browser. So if you're in Safari or
And so the mobile apps don't.
So on iOS, the mobile
listen?
apps do support HSTS, but it's very. I'm not even sure what it really does because there's some level of support, but it's not like in the browser. So HSTS is mainly for the browser. Yeah. All right. I guess that's all. Thanks, everyone.